Yun na po.
Okay, yun. So, there you go. So, good evening again, Josh, and welcome to another session of Analytical Chemistry. This time, we'll be having Chapter 3, no, Chemical Equilibrium. So, last night, we ended up with what topic, Josh? Ano yun?
Aqueous equilibrium po.
Okay, Aqueous Equilibrium is specifically what?
Specifically ano po?
Hmm.
Ano po?
Anong concept? Yung mga substances mo, we tackled about what?
Yung wait. Yung aqueous solutions,
Mm-hmm.
solubility rules, yes, acid-base
Mm-hmm.
concept,
Yun na. So, we ended up with that one, acids and
acid-base
bases.
theory po.
Yeah. Mm-mm. So far we discussed two theories, no? What are those? You recall? Ano yung two theories na na-discuss na natin so far?
Arrhenius,
And?
Bronsted-Lowry.
Okay, good. So, but as a review, no, quick review for last night, we discussed about this, the acid base. We already started with aqueous equilibrium, but we're not yet dealing with chemical equilibrium per se, but we started with acid base description first. So, this will be your physical properties, no, ng acids and bases. We're done with this one. And then this will be the theories or definition ng acids and bases. Chemical definition this time because what we want is to describe acids and bases na base sa chemistry nila, no? So we have the first one is si Svante Arrhenius, no? So he offered the definition. Ano yung
Siguro naman
acids?
po, for this time, other than ammonia siguro, pretty
Ah,
good ano po, pretty good theory.
yeah, the Arrhenius definition is a pretty good one because Arrhenius just left out yung mga ammonia compounds, so amine tsaka ammonia. Actually, meron pa siyang nakalimutan, Josh, eh. Yung mga ah, metals mo, transition metals. Nakalimutan niya rin yun. Okay? So, ah, ano yung mga transition metals? Naaral na natin yan eh. Acid or bases?
Acid.
Di ba? Kasi dun sa ano natin, sa coordination chem, there are what? Anong type ng acids?
O,
Anong type ng acid yan? Kahit hindi pa natin na-discuss yung third theory, dapat alam mo na yan.
alam ko na po, wait lang. Alam ko na po eh.
Yan yung third definition.
Yes. Bron Bronsted Lowry ba siya?
No, they're not
Wait lang, opo,
Bronson-Lowry
opo.
acids.
Yung isa pa.
They are what? Yun kasi yung na-left out din ni Arrhenius eh. Yung mga transition metals. So, si Arrhenius, ang na-left out niya sa bases,
Louis.
correct, Lewis acids. Si Arrhenius, ang na-left out niya sa bases, si amines and yung ammonia compound. No? So, amine compounds, saka si ammonia. Yun yung na-left out niya sa bases. Kaya nag-offer ng another definition si Bronsted Lowry. However, si Arrhenius, naiwan niya naman sa acids yung mga transition metals. That's the reason why he proposed another theory or someone proposed another theory to cover the transition metals. The usually transition metals, that will be your Lewis acid-base definition. But however, as a review muna, ang Arrhenius, no, pag acids, Josh, ano yung i-yield nila sa water? If you place them
Ah,
in water,
H plus pag acid, tapos yung OH minus pag
very
base.
good. Or proton, no? So, or H2O plus. Pag acids, ano yung makikita mo sa formula nila? They have
They
what?
have H in their, ano.
In their formula. Pero please take note ha, tignan mo to Josh ha, tignan mo yung sa slide natin. Acidic H yung nilalagay ko, tsaka basic OH. Kasi minsan, let's say, sa acetic acid, CH3COOH. Sino lang yung acidic dyan? Sino lang yung acidic? Sino lang yung acidic, Josh?
Ah,
No, CH3COOH. Your acetic acid.
Sa ano po, sa Arrhenius po ba?
Arrhenius definition, di ba ang nakalagay kasi diyan, kaya hin-highlight ko, yung mga acids mo, they have acidic hydrogen in their formula. Let's say you have
I think acetic acid na po
CH3COH.
has acidic
Oo, asan yung acidic hydrogen niya diyan?
sa huli po.
Okay, eto 'no. So, apparently si acetic acid hindi siya gano'n pumapalo nga sa formula, eh. Kasi usually saan yung mga acidic hydrogen mo? They are written in what? Usually in front, no, ng formula nila. However, for your acetic acid, it's written dun sa medyo dulo, no, na part ng kanyang formula. So, ayan. And then, yung OH mo naman, you have basic OH for bases. O, next, punta tayo sa Bronson Lowry. Pag Bronson Lowry, Josh, anong definition natin ng acids? Bronson Lowry.
Proton donor.
Okay, proton donor. Example ng proton donor.
Ano kaya? Any acid po, mga HCl.
Correct. So, kapag bases naman, proton acceptor sila. However, pag Bronson Lowry, ang nangyayari, once your acid loses its proton, what will happen to your acid?
Becomes
It will
conjugate
become
base.
conjugate base, very good. And then your base accepts an proton or hydronium ion, it
Conjugate
will
acid.
become conjugate. So you have conjugate acid-base pair system dito. Okay, so with that, I'll be sharing say ano tayo. Asa na ito? I'll just share a new one, whiteboard. Ayan. So nakikita mo na yung whiteboard ko, Josh.
Opo.
So, let's say we'll have this one. No, not that one. Pwede mo. Not that. Pwede na yan. Let's say ito, Josh. CH3 and H2. And then, plus water. Yeah. What will be your product? Sige nga. CH3 and H2 plus water.
Okay. So, CH, dapat NH, wait lang. So, H2O may giging OH.
Hindi, decide first sino yung magiging base and acid. Which one is your base?
Base CH3 and H2. Amine.
Very good. So, kasi ito ay isang amine, methylamine to be specific. Tapos si water ang acid. So, water will become what again? Nasabi mo na tama.
Acid.
Water will become acid, yes. Pero after losing proton, so kasi siya proton donor mo, di ba?
Magiging conjugate base which is OH.
Okay, OH what?
OH minus.
And then, what will happen to your base? CH3.
Base magiging CH3 and H3.
Okay, tapos may charge ba siya?
Yes. Plus.
Nasaan ang charge?
Nasa H po.
Hindi, I mean, nasa ang atom.
Nasa NN?
N, dapat nasa N yan ha. Kasi if you will recall, di ba yung ammonium, kasi derivative lang dito ng ammonium ion eh. So, yung hydrogen mo, ayan, ganyan. Then, ito yung methyl mo, no? So, yung positive charge is sitting atop your nitrogen atom. Okay? So, this is your conjugate base. Tapos, ito yung conjugate acid mo. So, ito yung base pair mo, no? Ayan. Okay. Ayan, magbibigay ulit ako ng another example. Tapos, ikaw this time lang yung mag-identify nung mangyayari, no? So, isip ako. Let's say, ito. H2PO4 negative. And let's say we have here NH3. Josh, please predict the products.
Products. Bisulfate. Wait no? Ito.
H2PO4 yan.
Dihydrogen phosphate. Ba't ko sinabi
Mhm.
ko sulfate?
I don't know.
Is there any other way to say dihydrogen?
No, dihydrogen phosphate talaga siya.
No! When
Kasi
chemists,
biphosphate is HPO4 negative.
when chemists who are fond of ano po, of yung mga, may tawag po yung mga water ammonia, don't have a word for dihydrogen. NH4 plus and bisulfate, biphosphate.
Okay, good. NH4 plus and then biphosphate. So, anong formula ng biphosphate?
HPO4.
HPO4?
HPO.
HPO4?
Wait a minute.
I need
2
the
minus,
charge.
2 minus.
Okay, 2 minus. If you will notice, yung mga sides ng equation mo, if charge sila, balance pa rin yan. Tignan mo sa umpisa, yung sa example. This is net zero charge, no? Tapos, ang net din ng kabila, zero din. However, dito sa second example natin, Josh, negative 1 yung net. Supposed to be, dapat yung sa kabila mo, negative 1 din. Negative 2 plus 1, negative 1. Okay? O, may tanong ako, sino yung conjugate acid base pair system mo? Lalagyan na lang natin nung parang connector. Conjugate acid base pair lang ang hinahanap ko.
Yung NH3 and NH4 and
Okay, good.
dihydrogen phosphate and biphosphate.
Okay, yan. So, yan. So, babalik na ako dun sa aking sinishare. So, we're good with that one. Balik ako dun sa aking slide. Then, ayan. So we're clear with Bronson Lowry, no? So please take note, meron pa akong mga additional notes for Bronson Lowry. Please take note that the strongest Bronson Lowry acid will produce the weakest conjugate base, and strongest Bronson Lowry base will produce the weakest conjugate acid. So that's the reason why in this case, si perchloric ay a very strong acid. So therefore, perchlorate will become one of the weakest bases in that we know, no? Sa example niyan. Okay. So before we proceed with the Lewis definition. Si Lewis definition kasi hindi siya ganun ka-useful pa sa puntong ito, no? Pero daanan na lang natin siya. Sige, unahin na natin to. So, when you say Lewis definition, kung ang Bronson-Lowry definition, Joshua, PDA to ha, just remember the acronym PDA. Pag Lewis naman, EPA yan. EPA. Okay? Electron pair acceptor acid. Kaya,
Naisip ko
pag
ng
ano ha,
Bronsted.
pag Bronson-Lowry PDA, pag Bronson-Lowry PDA, proton donor acid. So, automatic proton acceptor na yung base. Pag Lewis naman, Lewis definition, electron pair acceptor acid.
Opo, yung
Tas,
acceptor magiging donor po sa Bronsted.
yeah, correct. Oo. Very good. Baliktaran yan sila ni Bronson-Lowry tsaka ni Lewis. Kasi ang tinitignan ni Lewis, instead na, di ba si Bronson-Lowry, anong movement yung tinitignan niya? Movement nino?
Ni proton.
Okay, ni H+, no? H+ movement ito. Pero, si Lewis naman, ang tinitignan niyang movement ay electron pair. Okay? So, ngayon kasi, Josh, si Lewis, siya yung nag-open sa mga transition metals to be included in acids. Kasi yun yung nakalimutan ni Arrhenius. So, di ba si Arrhenius, parang nawala sa Arrhenius definition si ammonia tsaka yung amines, no? And other bases. Ngayon, si Arrhenius naman, nakalimutan niya rin yung mga transition metals. And yung ibang element na nag-act as acid. So, kung maalala mo to basic na reaction, sige nga, di ko alam kung matatandaan mo to ha. What is the product for this one, Josh?
Oh no.
BF3 plus
Wait lang po,
F
wait lang.
minus.
I still remember this.
You can do annotation
BF4
and then draw.
minus? Parang magana po siya, diba? May BF4 minus.
Sige, pakita mo kung BF4 minus.
I have no idea po. Wild guess lang po.
This is nice. Sige, go ahead. Pakita mo yung sa
Ano po lang.
O hindi, pakita mo. Na-discuss na natin yan. Oh.
Ah,
Isulat mo dito. Ayan. Oh, lalagyan kita ng space dito. Para lang makita natin. Oh, sino yung acid muna, sino yung base? Kasi ito, ang Lewis din ay
so HF
gamit
po
din
is
sa
acid.
organic.
HF po is acid, so this must be base.
Very
Wala
good.
po yung stylus eh.
So, Lewis base yan. Okay, tama. That's your Lewis base. Ito yung Lewis acid mo. So, ibig sabihin, ako yung mag-ano, Lewis acid. So, ibig sabihin, Josh, kay nino manggagaling yung electron pair? Hoy, kailangan mo itong matutunan dahil sa organic, ito rin yung aaralin natin. Kay
Electron
nino
pair
manggagaling yung electron pair?
ni F.
Ni fluoride. So, ngayon,
Correct.
pair to ha. Tapos, ito yung tinatawag nating arrow pushing. Josh ha, nagkakaroon ka ngayon ng mga arrows to denote the movement of your electrons. Kay nino pupunta yung dalawang electrons mo? Kay nino pupunta yung dalawang electrons mo? Saang atom?
Sa B, boron.
Okay, kay boron. So, pupunta ngayon yan. Tapos, yung arrow mo dapat nakaturo kay boron, ha? So, yung start nito, yung parang terminal mo, papunta dun sa, yung head ng arrow, papunta kay boron, indicating that the movement of your electrons is from fluoride going to your boron atom in BF3. Tapos, magiging ganito siya. Ayan. So, ano ang BF4? That's correct. BF4 ito. Tapos, ano ang charge ng BF4?
Negative.
Okay, good. Kasi negative yung overall charge ng reactant side mo eh. So, dapat yung product side mo, negative din. Okay? So, BF4 negative. Anong tawag natin dito? Naalala mo yan? Hoy, ilang beses na natin ito nadaanan.
Complex?
Ha? Hindi
Wait,
to
it's a complex?
complex din naman. It's a complex pero
No way, it's a
we call
complex.
this one a
Mm,
Lewis acid base adduct. So, yan. Adduct yan. Okay? So, naalala mo yung adduct? Kasi addition sila ng dalawang compounds, then product side siya. So, it's an adduct. Lewis acid-base adduct. Okay? So, pero sa mga transition metals, complex yung nabubuo natin. So, pag transition metals, sino yung acids mo dun, Josh? Kunwari, complex formation. Complex formation, Josh. Sino ang acid?
acid si BF3 tapos
Hindi, complex formation na tayo. Oh, you're
complex
not
formation.
listening, ha?
No.
Oh.
Acid ligand ba or ano? Ligand.
Sino ang acid? Ligand or yung metal?
Wait. So yung ligand will give. So acid yung metal?
Okay, acid yung mga transition metals. Yun yung na-include ngayon sa Arrhenius acid, sa Lewis acids, no? So, acid din kasi yung mga transition metals. And then, yung bases mo, yung mga ligands. Yung mga bases, usual yun yung mga ah, electron pair donors. Anong masasabi mo dun sa mga ligands mo, Josh? Kasi electron pair donors sila eh. Anong type sila ng electron poor or electron rich? Ayan na. Nag-aano na ako ng electron pair or electron poor or electron rich.
Hmm.
Ano, electron poor or electron rich?
Electron rich yung ligand. Tapos yung electron
Ligand. So, ibig sabihin, ang mga bases in a general sense, yung Lewis bases ay what? Electron rich or electron poor?
yung yung mga ligand.
Lewis bases, Lewis bases. In
Lewis
general.
electron
Kasi ang ligands mo ay
electron
bases
rich.
eh. Okay, so electron rich sila ngayon.
How could a
Ako, tandaan mo to ha.
how could a Lewis base possibly have how could it possibly be electron poor but somehow give?
Yes, exactly. Yun yung concept, right? So, how come the bases will be electron poor? Because there will be electron pair donors. So, definitely, they're electron rich. If they're electron rich, Josh, in connection as organic, what do they like? Anong gusto nila? Anong species, ang charged species ang gusto nila? Positive or negative species? They will be attracted to what? Ligands mo, Lewis bases, they are electron rich. They will be attracted to what?
Electron poor.
Electron poor or positive species. Okay? So kaya ang tawag natin sa mga bases, Lewis bases din sa organic ay nucleophile. Yan. So
Okay.
introduce ko na. So, inintroduce ko pa lang nucleophile. So, of course, philia means love, no? Nucleo means positive. So, positively species loving itong mga to. Kasi nga, electron rich sila. They're usually negative, no? Or neutral in a sense, but they're electron rich. They will be attracted to electrophiles or dun sa mga positive species. Nucleophile ang tawag natin sa kanila. Okay? So, yeah, we're good with the Lewis acid-base definition. We'll go back sa Lewis acid-base definition once we go back dun sa transition metals, no? Lalo na yung sa titration nila, at saka chemical equilibrium nun. And pag pumunta tayo sa organic, mamimit mo ulit yan. Okay? So, ibig sabihin, dapat dadaanan na lang natin itong mga definition na to, ha, sa organic, Josh. Dapat alam na alam mo na siya. Okay? Let's proceed. So, of course, the number of H plus, acidic H plus or basic OH, depends on the compound itself, di ba? Kapag isang hydrogen lang yung pwedeng matanggal or ma-ionize dun sa compound, anong tawag natin dun, Josh? Anong type ng acid? It's kunwari, HCl.
Monoprotic? Ay, wait lang.
Okay, good. Tama, tama. Monoprotic yun. Monoprotic kasi isa lang eh. So, example nito, HCl. Ano pa? Example, aside from HCl.
HNO3.
Okay, ano pa? Weak acid naman.
CH3COOH.
Okay, good. So, those are some examples of your monoprotic acid. If you have two or more than one ionizable H atom per molecule, that will be a polyprotic acid. So, pag dalawa, anong type ng acid yon? Pag dalawa, anong type ng acid?
Diprotic?
Diprotic, correct. Kapag tatlo,
Triprotic.
usually, okay, hanggang dyan lang naman usually, eh, no? So, pero meron pa rin mga, ano ha,
Polyprotic.
tetraprotic o kaya polyprotic acids pa, no? So, pero very few na
Meron pa
lang
po.
yun. So,
Meron pa po.
hmm,
Yung third,
yes.
yung organism. 118.
So, what do you think if you can form acid out from organism, what polyprotic acid can it form?
118 something, what do you call that?
I don't know. So, ngayon, we'll go back sa mga K-values nila. But so far, by naming muna tayo or by familiarity, we have monoprotic acids, meaning they have H plus, no? 1 H plus, ionizable H. Diprotic acid, they have 2 ionizable H, and then triprotic, 3 ionizable H. Okay? So, yeah, we're good with this one. Amphiprotic substances, 'di ba? Sino nga ulit yung amphiprotic substances? Sila ay they can act as what?
They can act as any acid or base.
Okay, good, no? So, kung Bronsted law yung sinusundan natin, they can act as a proton donor or a proton acceptor as well. Wait lang dyan siya, very fast. Okay, so if you will notice here, Josh, what can you say about your amphiprotic substances? Tignan mo yung mga nandito sa examples. What can you see? Okay.
Amphiprotic.
Oh, amphiprotic substances sila. Pero what can you say about their structures or their formula?
Lahat sila may negative usually or neutral.
Either negative or neutral, pwede, correct? Or, meron pa,
Or neutral or may
meron pa. Tignan mo lang yung
Ano
ano
po
nila,
yung
structure and formula.
hydrogen?
Correct, may
Sa
hydrogen sila.
yung hydrogen na po, not part of it, not part of yung ano po,
Mhm.
not part of yung hydrogen, not part of yung structure mismo.
Yes. Yung hydrogen mo mismo, pwede siyang mawala or madagdagan. No? Yun yung mga amphiprotic substances. Amphiprotic substances will have hydrogen na pwedeng they can lose it or they can be ionized. Yun yung term natin na when you say ionization, Josh, it means you're losing your proton. Let's say HCl. So when you say HCl is getting ionized, you form ions. So magiging H plus and Cl minus siya. This is ionization. Okay? So in aqueous equilibrium ito ha, baka kasi isipin mo, di ba ionization, sir? You form ions, tapos tinatanggal natin yung mga electrons, etc. Yes, that's true naman. It's still ionization pa rin. Pero, pag sa aqueous equilibrium, you're removing only proton, yan, ionized, no? Or you're forming ions in a general sense. Okay? So, please take note, let's say we'll have bicarbonate. So, para lang ano natin. O, ikaw ngayon mag-share, Josh. Share your whiteboard. Bicarbonate.
Bicarbonate structure lang po. It's such an easy.
Hindi. Hindi structure siya. Yung pakita mo sa akin na si bicarbonate ay kaya mag-act as acid or base. Depende dun sa kasama niya. Sige nga. Go ahead.
Okay. So, wait.
Carbonate.
Carbonate lang po?
Bicarbonate.
Bicarbonate. Wait, ano ba yung structure ng bicarbonate? Wait.
Formula niya ay HCO3. What?
HCO3 minus po.
Okay, o sulat. Ipakita mo sa akin that bicarbonate can act as an acid and base. Kasi alam mo, amphiprotic siya eh.
Let's see po kung if I can draw it well.
You don't need to draw the structure. Ano lang, yung ginagawa natin, yung parang equation.
Ano pong equation?
Equation, kasi ipapakita mo sa akin na ano siya eh, acid or base siya eh.
Okay. Hindi po kailangan nakipakita yung mga electrons dito.
Yeah, oo, hindi. Kaya pwede mong i-type.
Pero anyway, dito naman.
Yan, okay. So that's HCO3 minus.
Okay, so siya mag...
O, ngayon, paano mo ipapakita ang acid siya? Paano mo ipapakita ang base siya? Siyempre, lahat may magre-react sa kanya.
Okay. So, bicarbonate. Let's see. Think. Ano ba? Kasi yung ano po can form acid
So, bicarbonate is what again? Anong type siya ng substance? Acid, base, or neither?
amphiprotic.
Amphiprotic, very good. So, it
Ano po
can
po?
act as an acid or
Ano
base.
yung conjugate acid na po is carbonic acid.
So, paano mo bubuing carbonic acid yan? React it with a strong acid.
Something that has a lot of H. Yes.
Yeah. React it with strong acid.
Dapat po nasa lab po ako para mainom ko po. Tapos we can see
No.
it reacts.
That's your bicarbonate, correct? I mean structure.
Bakit maliit yung X? Mumukha siyang coefficient.
Why are you writing X there? What are those? What are those X?
Ano po? Any alkali? Baka Na. Palagay ko nga lang.
Hindi, okay na yan. Yan. Tapos, kung acid C, Ilagay mo muna kung sino yung acid, sino yung base para malinaw. Good. Tapos lagyan mo kung sino yung conjugate acid, kung sino yung conjugate base. Check mo yung yung formula mo ng sulfate, ng conjugate base mo rather. Ilan lang yung nabawas sa kanyang proton? Oh, you see. Oh, O2 minus siya, pag ganyan.
Wait,
May
wait.
naiwan ka pang proton.
So, HCO3, H2CO3. Ah, okay, may naiwan sa kanya.
Okay,
Bisulfate.
correct. Kasi naging H2CO3 yung isa eh. Ayan. Tapos tignan mo yung overall charge nila. Conjugate acid. No?
Overall charge. Okay,
Kunwari, yan, sa negative, sa reactant side, ano ang ano?
0.
Z,
Negative.
okay, good.
Negative. 0. Okay, may
Okay, good. So, balance siya, di ba? It makes sense. Ngayon, give me another reaction naman na this time, si bicarbonate ay acid. Mag-a-act siya as acid. Go ahead.
Okay.
So,
So,
this time, i-react mo siya, of course, sa isang.
what is
Siya
the
yung mag-a-act as
ano
base.
I see, I see.
Ay, sorry.
Ano po,
Siya yung mag-a-act as acid.
lahat po ng mga bi, they have the opportunity to become diprotic.
Very good. Oo.
Or
Ano
they
sila?
have the ability to turn into like their
Pwede silang
unbind.
amphiprotic.
Ano,
Yes, pwede silang amphiprotic.
how do you call it unbind po? Yung wala siyang hydrogen. Deprotonated. Ayun, deprotonated.
Deprotonated, yes.
Yay.
No hydrogen at all. Correct. Deprotonated species. Okay, so ngayon, this time, yan ang acid.
Okay, so paano siya matatanggal?
Ganun.
Alam ko po.
Correct. Mag-isip ka ng base, o edi, a strong base.
Strong base. LIO. Wait lang.
Go ahead.
Super strong base. Na magkano siya? Alam ko po. Rubidium. Ah, wait, no. Ano pa? Ano ba yung, LIO ba yung strongest na,
LiOH, lithium hydroxide.
Hindi po eh. Wait lang. Ah, yes. Methyl.
Yeah, pwede yan. Good. At yan. Okay na base yan.
Methyl
It's a strong
ionize.
base. It's a strong base.
I think it's the strongest base po. Hindi ba po siya
Alam ko
strongest
hindi.
base?
Hindi.
Ano ba yung
Pero
strongest
strong,
base?
very strong yan. Naalala ko nga eh. May mga inorganic ka na strong base talaga.
Ah, diethynyl benzene dianon.
Yun daw ang strongest base. Check
Hindi
natin.
po. I think I remember. Ortho ba or meta? No. CO3. Plus.
Ortho-diethynyl benzene dianion. Organic siya. Diethynyl benzene. Kasi yung benzene ring, yun yung super base siya. It's a super base.
Super acid po meron.
May mga super acid din.
I think
May
yung
mga
po, yung
inorganic.
sinasabi ko nga po, yung
Fluoroacetic acid.
antimonic acid.
Antimonic. Okay. Yeah. Okay. Okay, conjugate base.
Okay po yung spelling.
And if you will notice, tignan mo to, Joshua, I will also annotate. Kapag sino yung, ibig sabihin si bicarbonate ay nasa gitna, no? Correct?
Opo.
Tapos, kapag nag-add ka ng hydrogen sa kanya, so ibig sabihin, siya yung mag-a-act as what? Proton acceptor siya. Pag nag-accept siya ng proton, ano siya?
Mhm.
Proton
Yung
acceptor,
proton acceptor siya, it will become yung on the acid, which is carbonic.
H2CO3. Okay, carbonic acid. Tapos,
Naman.
kapag nag-act, pero nag-act siya as what? Kapag proton acceptor siya.
Akala sa CO3, magiging CO3.
Hindi. Nung nag-add ako ng hydrogen sa kanya, ng proton, nag-act siya as what? Acid or base?
Siya naman as an acid.
Hindi, nag-act siya as what? Kapag nag-add ako ng hydrogen sa kanya.
Acid.
Acid siya pag nag-act ako ng acid,
Ah,
ng hydrogen sa kanya.
nag-add ng hydrogen.
Proton acceptor siya. Yes.
Base siya, magiging acid po siya.
Yes, magiging H2CO3 siya. Pero si
Yeah.
bicarbonate ay ano?
Base.
Base, correct, no? So if proton, if bicarbonate accepts a proton, it acts as a base, no? As a base to form carbonic acid. However, if your bicarbonate donates hydrogen or proton, it will become what? Your carbonate ion. So bicarbonate this time is acting as an acid. So yeah, this is your acid route and this is your base route. Okay? So yeah, okay, mag-share ulit ako ng aking screen. Let's go back. There you go. Yeah. So, we're good with this one, amphiprotic solvent. Tapos, autoprotolysis or autoionization. When you say autoprotolysis or autoionization, it means your substance is reacting to itself. No? So, sino kaya yon? Anong example ng autoprotolysis or autoionizing substance, Josh? Can you give me an example?
Uh-huh. I have no idea.
Hmm? So
Wait.
let's say ito, sige, simulan natin kay water. Di ba si water kaya niya mag-act as acid and base? Correct?
Yes, amphiprotic
Amphiprotic sa
po.
water. O, ayan. Ah, So, paano kapag may dalawa kang water molecule? Di ba? Pag may dalawa kang water molecule, so, ito magdo-donate ng proton dito. So, you'll form what?
You will form, wait, that's the autoionization.
Auto-ionization of water ito. This is the auto-ionization reaction of water. Auto-ionization of water. That's correct. Auto-ionization of water yan. So, you'll form what? You form
What? OH minus and H3O.
okay, good. Ngayon, ito Joshua, ito yung clue. Si water ba ay solvent? Si water ba ay solvent?
Yes.
Ngayon, kapag nag-auto-ionize yung solvent mo, kung ano yung species na nabubuo niya, yun yung strongest acid and strongest base in that specific solvent. So, sino ang strongest base in water?
OH.
Correct. Ito ngayon conjugate base mo siya, no? Ito ngayon, si OH minus, siya ang strongest base in water. Kasi siya yung nakuha mo sa autoionization. At si hydronium ion, siya ang strongest acid in water. Kaya nga, di ba, kapag kumukuha tayo ng pH, ano ang tinitignan natin? Kapag sa aqueous solution? pH. What do we want? What concentration?
H. P.
H
pH.
plus. Correct, 'di ba? Si
Okay.
H3O plus or si H plus because siya yung strongest acid mo in water, no? So, ayan. Hydronium ion is the hydrated proton form when water reacts with an acid. Hydronium ion is your strongest acid in water. Take note ha, in water. So, let's have another example, no? Yung ano, um, alam mo yung phenol, di ba? Tama?
Opo.
Anong formula ng phenol?
Is benzene. But with
Benzenamide. Benzenamide, correct. That's
but has
benzenamide, ano?
OH. But has OH.
Correct. Benzenamide OH. Ganyan siya. Okay? So, or C6H5OH. Oh, ang benzene tuloy. Ang phenol, Josh, ay liquid. So, pwede siyang solvent. I'll stop sharing. Oh, ikaw mag-share ngayon ng ano mo, na whiteboard. Very important itong mga concept na to eh. So, ayan. This time, oh, ipakita mo sa akin ang ano ng phenol. Pwede ko naman i-select ko no, paano select? Para
Ah,
i-move ko to.
parang di-delete lang yata po eh.
Ay, di-delete lang siya. Oh. Ano yan, nagbagong page ka na lang or dinilit mo?
Nagbagong page po ako.
Okay, good.
Actually,
Ayan.
sorry po.
Sige,
I had to delete it. L. Tang 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 tang. Ano?
do the auto-ionization of phenol. Sige nga, that's
Ah,
your...
so other than water and phenol and other na may OH, are there any other non-OH based auto-ionization reaction?
NH3.
Wait, NH3
Ammonia. O
auto-ionization.
sige, ammonia. Sige, try mo ammonia. O ayan, o, tinanong mo sa akin eh. Yan, binigyan mo ko idea.
Ammonia is an
Yes.
auto-ionization?
Oo, kaya niya mag-auto-ionization din. Ammonia. Basically, parang virtually nga eh, yung mga solvents mo, kaya nilang auto-ionization. They can react with one another. So lahat, ammonia, binigyan mo ko ng idea, bago muna yung phenol, NH3, sulat, NH3. Dalawang NH3 magre-react with one another.
Okay, so ito muna. Parang yung NH3, I have no idea. So pangit ng
Ay,
wait.
hindi magkakaroon, madali nga yung NH3 eh. Kasi alam mo na kagad yung acid na mabubuo eh. Pero ayan, pwede naman yan. Pero ako I prefer yung below. Kasi may resonance yun eh.
Why do you prefer po yung bilog?
Resonance. Yan.
Why do you
Siya ang
prefer
mas,
the native po?
siya yung mas tamang representation ng benzene.
So bawal bawal po yung kekuli.
Pwede naman yung kay Kekulé. Okay din yun.
Dapat pa ibawalan na siya para
Kekulé structure nga yan eh, yung may ano eh,
mm,
yung
may circle po.
resonance.
Wala,
Oo, di ba Kekulé
hindi
structure yan?
yata po si Kekuli yung nag-propose
Alam
nun.
ko si Kekulé yan. Kasi siya ang nagsabi na nagre-resonate ang ano eh, ang benzene ring.
Ba't ang pangit ng drawing ko ngayon? Kasi walang graphics tablet.
Siya nga, Kekulé structure na may below.
Siya nga rin po.
Resonance, kasi nga resonance hybrid siya eh. Anyway, ayan, sige, go ahead. So, yung isa, mag-a-act as acid, yung isa mag-a-act as base.
Okay, so I'm going to die.
Is that a full reaction? Yes or no?
It's
Yung
a
auto-ionization.
yes, because it's a full reaction po because I drank the acid and then the base was
No,
therefore
yeah, very good.
full reaction.
Equilibrium lang din siya.
Kasi
It's a
it will
reversible reaction.
suddenly parang ano po yun yung energy magiging positron electron pairs bigla nito annihilate each other. They will annihilate each other again.
It's a reversible reaction, very good. So,
Phenol. Okay, wait.
okay.
Ionization.
Tignan mo. Tapos, ang clue mo dyan, ano yung charge mo sa reactant side? Overall charge.
So dapat
Anong
yung
overall charge mo?
overall charge.
Ng reactant side, pag tinotal mo. May charge ba yung phenol?
Wala po.
O, di dapat 0 din
Okay,
ang nasa kabilang side.
so this is really easy.
Correct, di ba? Kaya sabi ko sa'yo, madali lang din kahit yung ammonia. O plus okay. Kasi yung isa magdo-donate ng hydrogen eh. Okay, good. Pero, no. Ano yung
Kasi
charge?
po,
Ano yung charge?
every time po magkakaroon ng oxygen, lalagyan ko po ng G.
Every time you'll have an opportunity to write organism, you'll write organism. Anyway, what will be the charge of the two
Wait.
phenyl species or the benzene derivatives? Anong charge nung, yan, anong charge yan? Ilagay mo sa
Wait.
oxygen.
So
Kasi
yung
si oxygen,
oxygen po, lost H. So,
yes,
must
lows
be the
H.
base.
Lows H. Yeah, correct. Nag-lose siya ng H.
Oh wait, these are conjugates.
Yep, conjugate base and conjugate acid. Pero ayan na yung magiging strongest acids and bases mo sa phenol. So, may charge yan, Josh. Ilagay mo sa tamang atom.
So this one, tatanggalan siya ng positive. Oh yes, okay. So must be negative.
Very
So,
good.
tatanggalan siya ng positive. Okay, positive.
Good. Tama na. It's not a conjugate.
But it's a conjugate before the other one. Okay.
No.
So, neutral. This is the acid.
Yeah, that's your acid and the other one is your base. Oh, ngayon gawin mo yung ammonia. Kasi na-represent mo pa eh.
Ito po yung base.
Oh, ammonia ka ngayon.
Why does this have to be done on two people?
Eh, because you recommend that,
Why
right?
did I recommend it? Can we turn back time?
No. Oh, yeah, there you go. So, di ba? Easy.
Very hard.
And H2
This looks like a familiar
minus. Good.
familiar Indian symbol po. That is not Germany. It was not
Okay.
in Germany for the 1940s.
Anyway, so that will be your auto-ionization reactions, no? So I'll be sharing again my presentation so that we can proceed with another one. Another concept, important concept, nadadaanan lang din muna natin because we will meet this one in some other slides din ng Anakel. And, excuse po, and proteins. Actually, makikita mo to lagi sa katawan natin. Zwitter ion. So, what are Zwitter ions? Zwitter ions are substances that bear both positive and negative charge. So, I'll give you an example, Josh. Ang proteins ay gawa saan, Josh? Ang proteins. They are made of what? Proteins.
Proteins? Made out of something. I have no idea. I forgot.
Proteins
Sorry
are
po.
polymers.
Proteins are made of amino acids.
Very good. Amino
Yes,
acids.
okay, sorry.
Tapos tignan mo ha, ano yung amino acids? Amino and then acid. Eh di ba alam mo, ang amines ay what? Acid or bases? Amines.
Amines. Ano ba? Amines are sa
Derivatives of ammonia.
So, NH2?
Ano siya? Acid or base?
Base.
Base. Pero amino acid siya. So, ibig sabihin, your substance or your compound contains an acidic part as well. I'll give you glycine, the simplest amino acid. Kakabisaduhin mo to ha, yung mga structure nila pag nasa biochem tayo. So, tingnan mo to. Yan. So, this is glycine, pero neutral si glycine dito, no? So, NH2COOH. Kaya ka amino acid kasi may amino group. That's your amino group. Tapos, ano yung acid group mo? Si carboxylic group. I have a question, Josh. paano kapag deprotonated si carboxylic acid, tapos protonated si amino group ni glycine. So this is your glycine. So can you give me the protonated form of the amino group ni glycine? Just give me the formula.
Plus ano po, yung plus H.
N,
NH3.
sige, NH3, may charge ba?
Yes, positive.
Yes, positive. Tapos, carbon to, then may hydrogen ka dito sa taas, may hydrogen ka din sa baba. Then give me the deprotonated form of carboxylic acid. Deprotonated form of carboxylic acid.
And so COO.
COO, kulang
Minus.
lagi binigyan. Okay. What can you say about the molecule? Nasa iisang molecule lang yan lahat This is glycine. It's the glycine. Ano makikita? Ano masasabi mo sa
Both of them, they
molecule?
have a positive and minus, but it's not
Okay.
it's neutral, but it's not
It's
neutral.
neutral. Correct, no? It's neutral in a sense na overall, but it has charges, both positive and negative. Anong tawag sa mga molecules na ganyan? We call them,
Peter ions.
nandyan, Zwitter ions. Good. Yan ang concept ngayon ng Zwitter ions. Maraming mga Zwitter ions hindi lang mga amino acids. But amino acid is one of the most popular examples of Zwitter ions. Okay? So, ayan. Let's proceed. Yan yung concept ng Zwitter. Yung Zwitter ions kasi, pwede din silang, kung mapapansin mo, yung Zwitter ions, may carboxylic group tsaka amino group. Anong type sila ng substances, Josh? Acid, base, or neither, or what? May amino group sila, may carboxylic group din.
What do you call them? Carboamine.
Hindi, amino acids nga sila. Pero ano sila? Acid or base or what?
Both.
Both. Kung both sila, anong tawag natin doon? It
Peter
can
ions.
act as a Zwitter ion ay isang molecule na may positive and negative charge.
So what do you call
So,
these?
anong tawag natin sa substances na kaya mag-act as acid or base?
Amphiphoric. Oh my gosh.
Good. So, yung mga amino acids mo ay amphiprotic ano din? Sa amphiprotic substances. Okay? Or iba pa palang term dyan ay ampolite. Ampolite. So, they are polite. Wow. Nag-joke pa ako. Ampolite. Ampolite. Yan. So, ampolites are substances that can act as acid or base. It's another term for your amphiprotic substances. Okay? Let's proceed. So, ampolites. Ampolites din yung mga amino acids. We'll now proceed with R. So, the rest of the time, saktong-sakto we're 7:30. Siguro we'll end around 8:35 or 8:40. Dahil may rin ako, meeting Josh. So, we'll have the chemical equilibrium, no? So, chemical equilibrium, we'll be talking about the rest of the time about chemical equilibrium, no? So, ang chemical equilibrium, Josh, can be easily explained by using this one, okay? So, we have here a reaction diagram, no? So, we can see here the rate and then versus the time. So, reaction diagram kasi siya. So, what can you say? Describe first the reactants. Ano makikita mo sa reactants, Josh?
Reactants nag slowly becoming slowly going down, and then the products go slowly going up.
Okay, correct, no? So, because they're reacting, no? So, reactants are reacting with one another. Therefore, their concentration will go down. Then, eventually, their rate will go down as well because they're decreasing yung concentration nila. However, yung products mo naman, on the other hand, the products reaction rate is increasing because their concentration is increasing as well. But there will come a point na yung rate, I'm talking about the rate here. The rate of your formation ng product and the rate of formation ng reactants, dahil ito ay equilibrium, no, or reversible, please take note that the reaction is reversible. Nangyayari ito sa mga reversible lang. There will come a time na magiging equal na yung rate ng formation ng reactant and rate ng formation ng product. And we call that chemical equilibrium. So again, chemical equilibrium is the point wherein your system will have the same rates for your reactant formation and product formation. Make sure that the reaction is reversible muna. So if the reaction is irreversible, Josh, it's impossible for you to reach the equilibrium state or the chemical equilibrium state. So wala pong, kunwari yung ganito, HCl reacting with water, di ba alam natin magiging H3O plus yan, tsaka Cl minus. Full ito. So full, complete reaction yan, complete dissociation, complete ionization. So therefore, this will not reach a chemical equilibrium state or it will not have any chemical equilibrium. However, ano ang acetic acid? Strong or weak acid? Strong or weak acid? Okay. However, if you add or react acetic acid with water, since it's a weak acid, reversible ngayon siya. So magiging
Slightly strong.
CH3CO negative, correct, and H3O plus. So there will come a point na una, nagdi-decrease na yung reactants concentration mo, no? Because they're forming your acetate and hydronium ions. But eventually, your hydronium ions and your acetate ions will form back or will regain the products. So ngayon, if the rates are equal, you now have the chemical equilibrium. Chemical equilibrium is a dynamic equilibrium. Paano pag sinabing dynamic equilibrium, Josh? Anong meaning nun? Sige nga. If you
Dynamic
have a dynamic,
is completely move. It's like a changing. Parang yung clock, clock reaction.
yeah, dynamic equilibrium yun. Ibig sabihin ng dynamic equilibrium sa chemical equilibrium, the reactions do not cease, no? They do not cease. So, yung reaction do not ceases. The formation of reactants, the formation of products, it's tuloy-tuloy, no? Continuous. However, their rates are equal. So, the forward and backward reactions are still going on. Or reactions do not stop or do not cease once you reach the chemical equilibrium. Ang nangyayari lang, same rate ang formation ng products at ng reactants mo. Yun yung nangyayari sa chemical equilibrium. Kumalat yung mga ano ko. Wait lang na siya very fast. Tapon yung...
Average, what happens po when, what happens to me po when I forget about what I was drinking and then I suddenly move.
Ayan, I'm back. We're good. So,
Natapon po acid.
hindi, nalaglag yung mga, alam mo yung pamalit dun sa parang lead nung pencil, yung digital pen. Pinapalitan kasi ito parang graphite kasi ito para conductive. So, pinapalitan siya. So, ngayon, nabuksan yung, ayan, oo. Yung pinakatakip na buksan. So, tumilapon yung mga lahat. Anyway, nakuha ko naman lahat. Let's proceed. So, basta ang punto ko lang dito is during chemical equilibrium, the forward reaction and backward reaction, they do not stop. Instead, continuous yan. The rates will be equal. Ako ha, wag mo kakalimutan yan. Equal rate sila ha. Exclusive. Yan. So, the question here is that, how can we describe chemical equilibrium mathematically? Laging ganun, no? Quantitatively, how can we describe or how can we um, have a number for chemical equilibrium? So, we now introduce the chemical equilibrium constant. No? So, hindi ito bago sa'yo kasi na-discuss na to ni Sir James, correct? So, the equilibrium law and the equilibrium constant, K. So, di ba alam natin, the equilibrium constant is equal to, anong general formula mo dito for equilibrium constant? KEQ. KEQ is equal to what?
PEQ is equal to yung, oh wait lang, yung
Concentration ng,
concentration ng products
very good, products yan, over
times the ano to the ano niya
to its
to it
raised,
to its coefficient,
okay, raised to
and
its
then
coefficient.
over yung ano na yung what something what do you call that, the reactants raise their
Okay.
coefficient.
Actually kasi dapat X ang reactants eh. Gawin natin Y si products. Oh, very good. Products raised to its coefficient, then reactants raised to its coefficient. Okay? So, ayan. So, with that, we can now have the equilibrium constant. Please take note, it has been found experimentally. So, ibig sabihin, experimental ang paghanap ng equilibrium constant, Joshua. Experimental siya. For all processes, that the ratio of products to reactant is constant. No? So once you reach the equilibrium, ganito yun, Josh. Once you reach the equilibrium, the product and reactant ratio will always be constant at specific temperature. Kasi ito ay temperature dependent eh. Pakitandaan ito ha, temperature dependent. So please take note that the ratio between your products over reactants, once you attain chemical equilibrium, it's constant at a specific temperature. So how do we write equilibrium constants? Yun muna, very important concept. No? So, ang gagawin lang natin, alam mo na to, products over reactants, tapos i-raise sila dun sa um, stoichiometric coefficients nila. So, it means, Josh, you need to have a balance equation first. Very important. Balance equation. Ito ang uunahin mo ha. Number one to. Number one step. Pag nagka-calculate ka ng mga chemical equilibrium problems, ang number one step mo ay meron kang balance equation muna. So that your exponents will be correct. No? So please take note, there's a note here, no? So equilibrium constant expressions provide no information about whether a chemical reaction is fast enough to be useful in analytical procedure. That is the downside ng no, chemical equilibrium. Ang sinasabi ng chemical equilibrium, what will be the ratio of your products and reactants at chemical equilibrium? But we don't know how fast your reaction will be or how fast will your equilibrium be attained, no? So, gaano ba kabilis na, kunwari, nag-mix ka ng dalawang reactants mo, gaano kabilis nila ma-reach yung chemical equilibrium? Hindi yun describe ng chemical equilibrium. Ano yung magdi-describe ng Josh? If you want the fast, how fast a reaction can be.
Chemical kinetics.
Very good. Chemical kinetics yan, no? So, pero isa pa hindi kayang ibigay ni chemical equilibrium, yung mga heat involved dun sa reaction, hindi niya rin kaya yan. So, kunwari, spontaneity, hindi niya alam yan. So, sino magbibigay? Kung spontaneous or non-spontaneous ang reaction? So,
Yung ano niya, yung sa delta G.
very good. Delta G, thermodynamics, no? Or thermochem. So, kaya dugtong-dugtong yung tatlong yan. Si chemical kinetics, chemical equilibrium, tsaka thermochemistry. They're all interrelated. Isama mo na si electrochem. Si electrochem kasi specialized lang siya ng redox, no? Parang humiwalay lang yung redox reactions mo And then they created this whole big, big branch ng chemistry, electrochem. So, pero part pa rin yan ng chemical equilibrium pa rin, tapos may kinetics pa rin yan, then may thermodynamics ka. Those are all interrelated with one another. The next question will be, how do we write again equilibrium constants or chemical equilibrium constants? Please take note, Josh, kasama ba ang pure liquid and solid?
No,
Pag, good.
because I don't know.
The reason is that they have specific or constant uh, concentration already. Ano na, yung concentration nila, constant siya. Tingnan mo, ano yung concentration ni water? Naalala mo? Di ba si pure liquid? Ang water ay pure liquid eh. What is the concentration of water? Ay, naku, dapat alam mo na to.
I don't know.
Alam mo yung value. Uy, alam mo na yung value niyan. Get
Ikaw
the
ba?
concentration of water.
Concentration ng water?
Mhm.
Mm,
Kasi dapat ma-prove natin na constant ang concentrations ng solids and liquids eh. Kaya hindi natin sila sinasama sa equilibrium constant expressions. Instead, nandito na sila. They are already compensated to K. Again ha.
alam ko na po bakit. Kasi
Hmm.
they don't change naman. So why
Mhm.
should they equilibrate?
Correct, exactly, no?
Okay.
So, constant yung concentration nila. So, just include their concentration in your K so that it will become integrated already. So, ano ang concentration ni water? Para lang ma-prove natin, ayan, nakalimutan na. O, anong molarity? Formula ng molarity, Josh? What is the molarity of water? So, kunwari may 1 liter ka ng water.
And then,
Isang litrong tubig, how many grams?
oh no.
Approximately,
So, 4 grams ba? Ay, wait.
1
kilo,
liter?
1 kilogram, 1 kilogram.
1 kilogram or 1,000 grams. Anong molar mass ni water?
Mm-hmm. Molar mass ng water.
Mhm.
15.9994, mga 16 plus
Molar mass ni water. Okay.
18?
18. 18 grams per mole. So, ano ang molarity niya? Approximately. Yan 1,000 over 18 divided by. That's the molarity of water. That's the concentration of water. So, every time you will
1,000.
drink water,
1,000 divided by 18
over 1.
over 1. Over 1?
Kasi,
So,
over liter eh.
55.6.
Okay, 55.56 molar. Every time we will drink water, we're drinking 55.56 molar of water. Ang concentrated, no? A highly concentrated substance, di ba? Pag ayan! Hindi mo na kailangan mag-joke, Josh. Actually, you're always drinking a very concentrated solvent. 55.56 molar, ang taas niya, no? So, si water ay a very concentrated na substance. And then, if their concentrations are constant, we can now integrate it in your equilibrium constant. Kaya hindi na natin sila sinasama sa equilibrium constant expression. Okay? So, let's understand first K. No? So, what does K mean? So, if K is a big number, K is greater than 1. No? So, anong meaning nun? Sino yung mataas? Yung numerator or denominator? If K is greater than 1. Sinong malaki yung value mo? Products or reactants, Josh?
Products.
So, it means anong pinifavor na reaction? Yung product formation or
Product formation.
okay, or the forward reaction is favored. Therefore, a large quantity of products are present at equilibrium. So, malaki yung K mo, no? So, parang ganito siya. Reactants, ganito, tapos ganito. Kaya minsan makikita mo, ganito yung mismo mga arrows mo. Anong ibig sabihin yan? You're favoring the formation of products. So, let's go muna sa extreme, no? So, if K is a very small number, ano naman meaning nun, Josh? K is greater than what? If K is a very small number, ano naman meaning nun, Josh? You're favoring what?
Favoring reactant retention?
Okay, reactant retention or favoring the reverse reaction or formation ng reactant. So if that is the case, we will expect that at equilibrium, at chemical equilibrium, we will have a large number or large quantity of your reactants. Ngayon, ang tanong, paano kapag close to 1? No? Yun yung tanong natin eh. Paano kapag close to 1? So, ibig sabihin lang nun, equal quantities of reactants and products are present at equilibrium. Very sa mga substances, very seldom mo siyang makikita. Yung K is very close to 1. No? Konti lang yan na yung K nila ay equal sa 1. Usually, it's you go with the extremes. Very high K or very low K. Yan yung, sa Anakin, ito yung ma-check natin. Check and then check. Okay? So, we'll proceed. So, ngayon, ang K natin, Josh, ay different sa reaction quotient na tinatawag. I think na-discuss na natin ito, no? Or na-discuss niyo na siya ni Sir James. Reaction quotient ay Q. No? Q and K, they are different. Balikan natin. Sino si K ulit? K is your?
Kisi equilibrium constant.
And what is the formula for that?
Yung product equilibrium to the equilibrium concentration of the product to the
Over
reactant
equilibrium.
to the
Okay.
coefficient.
Ang mahalaga dito, pag K, Josh, we're concerned about the equilibrium state only. Ngayon, di ba, paano pag nag-start pa lang yung reaction, di ba pwede mo pa rin naman kunin yung product over reactants? Correct, di ba? Correct, Y, X. At any given time or at any point in your reaction. Yeah. So, kunwari, hindi mo pa nare-reach or na attain yung chemical equilibrium, we can still get the ratio between products and reactants. No? So we call them reaction quotient. So this is different from your K because your K is only concerned, or KEQ kumbaga, is only concerned for the ratio of your products and reactants at equilibrium. So ang reaction quotient, hindi. Ano siya, kahit hindi equilibrium, pwede natin kunin no, yung ratio ng product or reactants. Si K kasi, siya yung magiging standard mo para ma-predict mo kung saan pupunta yung reaction. No? So, we now compare Q and K so that we can know no, anong nasa ang state na yung mismong solution mo or yung mismong system mo. So, Q is calculated exactly like Kc or KEQ lang, no? Using the concentrations at that moment. Please take note at that moment, Okay? So, ngayon, if this is the case, Josh, if Q is equal to Q is equal to K, Josh, anong masasabi natin?
It's at equilibrium.
Okay, good. The system is at equilibrium. So, ibig sabihin, yung Q value mo ay same yung value ng K. So, ngayon, yung Q dito, i-compare natin siya ngayon dun sa KEQ. Minsan pala ang KEQ, ganito din siya. Pag KC kasi, naka-molarity yan. Yan, naka-molarity. Okay? So, KC is in molarity. Na-discuss to ni Sir James. Kasi may mga gases ka, di ba? KP naman yun. So, usually we don't deal with KP sa Anakin. We deal with KC. Pero in a general sense, KEQ ang tinatawag natin dyan. So, Q indicates which reaction, the forward or reverse reaction, must increase or favored so that we can reach equilibrium. So, paano kapag ganito? If Q is less than K. So, ano meaning ng Q is less than K? Mas
So,
mababa yung Q sa K mo.
ibig sabihin
Mas
po,
onti yung
mas konti po yung products form.
okay. So, if you have less product, saan pupunta yung reaction? Forward or reverse? Kasi less yung products mo eh, di ba? If you have Q less than K, mas onti pa yung products mo. So, saan pupunta dapat yung reaction to reach equilibrium? The reaction must shift what? Or must favor what?
Mhm. Mas favor reactant.
Oh, Q is less than K. Pag mas favor
Q na is
reactants,
less than Q is
papadamihin mo lalo yung reactants mo.
so if Q is less than K, then it will mas maraming in the end product, so more.
Pag Q is less than K, correct, marami pa yung reactants mo, pero gusto mo, onti pa lang yung products. So, sino yung papaboran mong reaction?
So products.
Correct. So, product formation will be favored. So, or mag-shift papuntang right yung reaction mo, no, towards the products. Para at least mag-equal yung Q and then K. So, the reverse will happen if Q is greater than K this time. So, if Q is greater than K, mangyayari lang yun kapag sobrang dami mong product. So, kapag marami ka namang products, kailangan mo siyang bawasan. So, the reaction will shift dun sa reverse side. So, the reverse reaction will be favored or towards your reactants. Shift to the left or towards your reactants. So, we have an example with this one. So, hindi ko pala yung sagot. Wait, i-hide ko lang. Para ano. Kunwari hindi mo pa siya nakita. Wait, where's the... I cannot see. There you go.
Trouble.
Wait lang dyan siya. Ipa-plug in lang ako ng laptop. Ayan. Then, yeah. Tapos, yung dalawa kasi yung problem eh. Oh, ano nangyari? Hmm. Oh, this is weird. Oh, okay. Ayan. Yan. Tayo. Ayan, may problem tayo. Binigay ngayon yung reaction natin. No? So the reaction here is formation of ammonia. So nitrogen gas reacting with 3 moles of hydrogen gas to form 2 moles of ammonia. So, is this balance? Yun muna. Sabi ko sa'yo, step 1 mo, balance equation. Is this balance? Of course.
Of course.
Swerte tayo. This is a balance equation. So, happy tayo. And then the K is given at a specific temperature. Like what I mentioned, Kc or KEQs are temperature dependent. So at 450 degrees Celsius, your KEQ value is equal to 0.064. Okay? So we have here a situation, no? So may situation tayo. So if the nitrogen gas is 4 molar, hydrogen gas is 2 times 10 to the negative 2 molar, then ammonia is 2.2 times 10 to the negative 4 molar. Which way will the equilibrium shift? I'll solve this one. So for the Q. So the Q expression is already given. or the reaction quotient expression. So it's just the same, no, with your equilibrium constant expression. So that will be ammonia raised to 2 all over nitrogen gas times hydrogen gas raised to 3. So if that is the case, ano ang ammonia mo? That's 2.2 times 10 to the negative 4 squared all over nitrogen gas is 4. Make sure that your ano ha, ang mga reaction quotients and K should be in molarity. The concentrations should be in molarity. Then hydrogen gas is 2 times 10 to the negative 2, then Q. Okay? So, hindi mo kailangan ngayon dito, Josh, ilagay yung mga units kasi numbers ang mahalaga dito. Just make sure that they're in molar. So, 2.2 exponent to the negative 4 raised to, this is raised to 2. Tapos yung isa ay 4 times 2 exponent to the negative 2 again, raised to this time raised to 3. So, ang answer ay 1.51 or 0.12151. This is your Q. So, your Q is 0.00151. What is this, Josh? Q greater than or less than K. So, yung K mo is 0.064. So, this time, Q is less than K. So, saan ang shift? If Q is less than K, ibig sabihin nun, Josh, konti masyado
Opo, konti masyado yung
yung
product.
okay. So, ang kailangan natin ay konti masyado yung product. So, kailangan natin paramihin yung product, shift to the right. No? Or, product formation. So, ikaw mag-solve nung nung second one. Binigay, binago ngayon yung sitwasyon. You have 2 molar for your nitrogen gas, and then it's still the same for hydrogen gas.
So,
That's 2 times 10 to the negative 2. Then your ammonia this time is 5.2 times 10 to the negative molar.
so po
Sige,
yung,
solve mo.
so,
Sige, ako magsusulat para iisa lang pala. O, dikta mo.
so yung NH3 is 5.2 times 10 to the negative 3. Okay, yes. So,
Negative?
the second,
Negative.
1 to the
Mhm.
second. So, sabihin, siguro 225 times 10 to the negative 2. So, mga 2.5, mga ganun somewhere along that line.
Mhm.
Estimate lang po, estimation lang. Yung isa naman, 2 molar times, ano ba?
O, syempre, ibibigay mo sa akin yung sagot dyan.
2.5.
Use your calculator.
Wala po yung calculator eh.
2 times.
Wala po yung calculator. Iyan ako po sa web.
2 times what?
2 times 2 times 2 to 2 times 10 to the negative 2 to the third power. So, mga 10 to the negative 6. Syempre. So, this must be huge.
See.
Must be very large. Kasi over, over 2 times 10 to the, over 8 times 10 to the negative 6. So,
Wala na, integrate mo siya. Oh, ikaw. Ayun. Anong sagot?
mga, so mga 10 to the, mga malaki po yan. Must be
Correct.
greater than 1,000. I'm sure.
Okay. Actually, ganito siya. Ito yung value sa akin. So, what can you say now about Q? Q is greater than?
Yung kailangan naman lang po, di ba? Greater than lang or less than.
Q is greater than K. So,
Very,
asan ang shift?
very right, very, no? What do you call that? Right word. Yung product forming yun.
Right yung madami. Or yung product, sorry. Product yung madami. Tama?
Opo.
So, what will happen to your equilibrium? Shift to the left or shift to the right? Or the reaction rather? Shift to the?
Right.
If it shifts to the right, you form more products.
Okay. So, shift to the left.
Okay. Or, para mas mabilis, reactant formation, no? Reactant formation will be favored. Yan siya. Next. Ayan. So, papasok na tayo sa equilibrium problem. Pero, ano ha, if you will notice, I'm refining your ideas dun sa equilibrium. Kasi alam ko may concept ka na nito. Pinosolidify lang natin siya. Nag-ice stable ka na nga, which is the next topic, no? So, ngayon, ito yung mangyayari, Josh. So, a simple problem. The solubility of lead iodide. Wait lang ha. Okay. Ako mabilis dito. Ayan. Gawin natin. Excuse me po. Gawin natin siya. Tapos, yan. Dito naman tayo. So, yan. Tapos, here. Okay. Let's now proceed. Let's have the story now of solubility of lead iodide. So, siguro feeling ko baka dito tayo matatapos kasi mahaba siya eh. May ano pa siya eh. May Le Chatelier principle na no. So, let's just study this case no. The solubility of lead iodide. So, lead iodide is what? Partially soluble or soluble in water.
Fully
Sige nga.
soluble.
Again,
Fully soluble.
fully soluble in water. Lead iodide ito ha.
No. Iodide.
Iodide ito, hindi iodide.
Iodide po soluble. Lead iodide.
Hoy, lead iodide, soluble.
Yung PBI2 po? Hindi siya soluble din.
Kasi diba kasi wait lang ha. Anyway, ayan, balik tayo. So let's study the case of lead iodide. So lead iodide is a partly soluble solid in water or partially soluble solid siya. So if you will notice here, if we will place lead iodide in water, you form lead ions and tsaka two iodide ions. So ayun, balance equation, masaya na naman. Masaya na naman tayo kasi balance equation. Tapos, ano yung associated ulit na equilibrium constant para sa mga partially soluble? Naalala mo? Anong type ng equilibrium constant?
I don't know. I forgot.
Oh, I forgot na sinasolve na natin yan dati.
Yung ano pa yung precipitation.
Precipitate siya eh. So, anong type ng ano? Tapos partially soluble siya. Di ba pag acid dissociation constant, Ka. Pag base dissociation constant, Kb. Paano kapag mga partially
KSP?
soluble? Yun, very good. Ano nga ulit meaning ng KSP?
Kay solubility product.
Okay, good. The solubility product constant. And using the way we write equilibrium expressions, paano mo siya isusulat? Let's say specific for lead iodide. KSP for lead iodide is equal to what?
Mm-hmm.
ASP for lead iodate is equal to what?
Lead PB IO32.
Okay, IO3 raised to 2. Bakit hindi kasama yung lead iodate sa baba, yung overreactant?
Kasi hindi naman siya ano, hindi naman siya fully aqueous.
Hindi siya fully aqueous, ganun ba yun?
Kasi
Hmm.
hindi po siya ion eh.
Hindi siya ion. Tingnan mo yung reaction.
Okay. So PB2 plus, yes, ion.
Why do we not
Kasi
include
solid. Kasi solid nga po.
yun? Solid kasi siya. So,
Mali pala yung third choice ko. I also know po
ekisa
na
mo
ano
na siya.
talaga. Hindi po siya ionized. Pero it
Hmm.
also meant na dapat hindi.
Meron at meron. Ito yung sinasabi ko sa iyo dati na ano, kapag may precipitate ka, it's impossible for us na sabihin natin, it's an insoluble solid. No, meron at merong nadidissolve sa water, pero hindi natin alam kung gaano kadami. Might be very, very few. That's the reason why we'll see the precipitate as is, no? Precipitating out from your solvent or out from water. So let's say lead iodate, no? So lead iodate is partially soluble in water, and if you will notice, its KSP is very small, 2.5 times 10 to the negative 13. So we can say that majority of your lead iodate will be insoluble in water. However, there will be ions pa rin, no, coming from your lead iodate present in water, such as your lead 2 plus and iodate ions. Okay? So, ngayon, ito ngayon yung scenario. At equilibrium, the solution is saturated already with PbIO32. Solid to, no? So, which means simply, no more solid can be dissolved. So, how do we determine the concentrations of Pb2 plus and iodate, no? So, or what is the molar solubility of lead iodate in this saturated solution? So, parang ganito siya, no? Pag mag pag may lead iodate ka, Josh, and you have water, lagay ka ng super onti lang na lead iodate, tapos i-mix mo siya, tapos darating yung point doon na may makikita kang solid sa ilalim. Pag may nakita ka ng solid sa ilalim, anong type na ng solution yun, Josh?
Ah,
Kasi naglalagay ka ng lead iodate, sobrang-sobrang onti nung una, tapos madidissolve yan kasi onti pa lang naman eh. Pero darating yung punto na pag naglagay ka ng lead iodate mo, you'll now start seeing solid particulate sa ilalim. What is that? You now form what?
precipitate po.
Oh, you know, you form a precipitate. Pero what type of solution was formed?
Type of solution yun for. Colloid.
Oh, colloid ba yun? So, meron
Then,
ka sa ilalim. It's an indication that you form what type of solution. Colloid, and colloid is not a solution.
ano ba?
Physical ano yun? Physical evidence yun na meron ka ng, anong tawag doon? Kasi di ba sa una, pag naglagay ka, nadidissolve yan. Pero darating yung punto, hindi na nadidissolve yung solid. So, anong meaning nun? You now form a what?
Hindi ko, saturated.
Okay, you now form a saturated solution. Di ba? Physical ano nga yun? Physical evidence natin na you already form a saturated solution if solids cannot be dissolved anymore. Saturated na siya. So, ang tanong dito, gaano kadaming lead 2 plus and iodate yung na-dissolve? Or what is the molar solubility of lead iodate as a whole? Gaano kadami yung natunaw na lead iodate? So, of course, to answer this, we will use the concept of chemical equilibrium kasi meron kang binigay na equilibrium constant. And we will use the table na KSP. So, KSP tuloy, ice table. So, when you say ice table, so alam mo na to, yung species ay nandito, usually, you separate the products and reactants. Kunwari, for this one, ito yung product, reactant mo rather. Then you have two products, product 1, product 2. No? Then, write the ice table. So, ice, I for initial, C for change, then E at equilibrium. So what you will be writing here for the different spaces will be um, will be their concentrations. Ang important dito, ito, si equilibrium concentrations. Kasi once we have the equilibrium concentrations, we now substitute that to your K expression. Eh, binigay ang K nung lead iodate. Meron kang KSP, no? So, we can now calculate X, no? So, with calculating na X, na ano na natin, no? Makukuha natin yung equilibrium concentrations ng mga species mo. Okay. So, with this, ayan, mag-ice table tayo. So, ice, initial, change, and then, ganyan tayo, equilibrium. So, this will be at equilibrium. May tanong ako, Josh. Ano ang ilalagay ko kay lead iodate? Solid.
Solid initial, wala.
Bakit?
Wala naman po siyang concentration. It's a solid.
Okay. So, at hindi natin siya ini-include sa equilibrium constant expression. So, ekisan mo kagad yan. Ulit ha, yun yung shortcut dito. If you see solids or liquids, ekis mo na yan. Do not include. Do not include in calculations. Okay. How about sa PB2+? Initially, meron ka ba? PB2+. Initially, meron ka, Josh? Wala, zero. How about your iodate? Iodate yan na.
Zero din.
Zero din. Pero, ano yung change mo dito? Plus or minus? Plus. At ilan nabubuo?
Yung molar na po ng PB, IO3.
Ilan siya? Magsisimbol tayo dito. Plus?
X yung PB, plus 2X yung iodate.
Very good. So, at equilibrium, we now have X na PB and then 2X for iodate. Tapos, ano yung KSP mo? KSP expression. KSP is equal to, balik tayo, PB2 plus times iodate squared. Squared, no? So, ibig sabihin, so that will be PB is X, correct? Tapos, 2X raised to what, Josh? 2X raised to
2 squared.
Okay. Which is equal to, ito yung value, 2.5 times 10 to the negative 30. So, pag-solve mo na to sa calculator, ano ngayon yung X?
I don't know.
So, we can actually combine this, no? 2X squared is equal to what?
2.5 over 2, which is 1.25.
2X squared is equal to 4X squared, no? Tama ba ako?
4x squared, 4, sorry po. So, 2
Yeah, 4X squared. Tapos, ita times ko pa sa X.
1.25 over 2,
4X cubed, correct?
0.625 na set to the negative 13. Cube root nun.
Correct. Very good. So, X is equal to the cube root of 2.5 times 10 to the negative 13 all over 4. Correct? Tama ba ako? Please, anuhin mo yung algebra ko. Correct, no? 4. Tapos ito. Sorry. Ito yung sagot. 3.96 times 10 to the negative 5 or 97. 3.97 times 10 to the negative 5 molar. O may tanong ko, Josh, sino yung X? Sino yung X ulit?
Yung how much concentration of PbIO3? 2.
PbIO3 po agad ba yun? Specifically, sino yung X? Tignan mo yung mga nasa at equilibrium.
PB concentration.
Okay, good. So, si PB2 plus, ayun, masasagutan na natin. Si PB2 plus ay equal sa 3.97 times 10 to the negative 5 molar. Tapos, paano si iodine? Anong concentration niya? Ita-times 2 ko lang siya, di ba? Tama?
Bro, sabihin ko po pa lang. Times 2.
7.94 times 10 to the negative 5. May tanong ako, what is the molar solubility? Sinong susundin mo? Si iodine or si Pb2+?
Okay. 2 plus.
Pb2+. So, ito din yung molar solubility mo. Kasi siya lang naman yung 1 eh. This is your molar solubility. Yeah, that is approximately 4 times 10 to the negative 5. So we know that your Pb2 plus is 3.97 times 10 negative 5 or approximately 4 times 10 negative 5, and your iodate ions will be 7.94 times 10 to the negative 5 molar. Wala akong unit to be molar. And then the molar concentration is 4 times 10 negative 5 or similar dun sa lead ion mo, which is 3.97 times 10 negative 5 molar. Ilan ba yung sig fig? Yung sig fig natin, wala naman, no? Walang sig fig na binigay. Kasi ang mga constants, Josh, no? Wala silang sig fig. Constant yan sila eh. So, indefinite ang significant value sila. So, we follow na kung ano yung binigay, wala nang binigay. So, gawin kong 3 sig fig. So, ito 2 sig fig lang kasi yung binigay niya, sinod ng problem. Tayo 3 sig fig. Okay? So this is the next topic, the Chatelier principle. So you know this already when you say Le Chatelier, principle, kapag nai-stress yung equilibrium, nag-a-adjust yung equilibrium so that you can relieve the stress. No? So again, when a chemical system at equilibrium is disturbed by a stress, no, the system adjusts, so or shift, no, so that we can oppose the change or lessen the stress. O kaya to remove the stress and retain the equilibrium or regain back or regain equilibrium. No? So what are the possible stresses in a certain chemical system? Kapag binago mo yung concentration, definitely magkakaroon ng change dun sa equilibrium mo. May stress yung equilibrium mo pag binabago yung concentration. So therefore, it will adjust or will react, no, in the side or in the it will favor a certain side of your reaction so that it will regain equilibrium. And then, pag binago mo yung pressure or volume, it might also, this one can also affect, no, the, the equilibrium. So therefore, magkakaroon din ng shift, no, either favors the reaction, the reactant formation, or the product formation. Then finally, change in temperature. So, depende din yan kung anong type ng um, reaction yung mismong system mo, no? Or yung system mo, kung once na-reach na yung chemical equilibrium, it will still follow, no? Yung thermodynamic parameters niya. So, the temperature will be adjusted or can affect the equilibrium as well. So, ngayon, ang tanong ko dito, Josh, how about yung presence ng catalyst? Can presence of catalyst affect your
Well,
chemical equilibrium?
hindi po. Yes. Baka either it could, wait lang. Yes, yung
Can,
ano po, mga, let's say, metal, it could speed up yung chemical equilibrium.
pero yung value ng chemical equilibrium, napapalitan niyo ba? Or yung mismong chemical equilibrium itself can be disturbed by
Di po.
uh, catalyst? The answer is no. Ha? The presence of catalyst or addition of catalyst do not affect or does not affect chemical equilibrium. Instead, chemical equilibrium will be attained faster. Yun lang yung meaning ng, yun lang yung effect ng catalyst. Di ba pinapabilis lang naman ng catalyst yung reaction? Ang mangyayari dito, pag nilagyan mo ng catalyst yung system, mas mabilis lang ma-attain ng system yung equilibrium, but it will not change the direction. It will not either favor the products or it will not favor the reactants, etc. Only these three: concentration, pressure, or volume. So, pwedeng 4 yan. Minsan kasi hinihiwalay yung pressure and volume. Concentration, pressure, volume, and then temperature. May summary tayo ngayon. So, ito, na-discuss na to ni Sir James nung Gen Chem mo, no? So, actually, binalikan nga natin yung binalikan na natin ito dati, no? So, yung pag nag-Chatelier tayo, para siyang siso, kumbaga, no? So, let's say kapag doon muna tayo, Diyos, sa concentration. So, kunwari, meron ka AA plus BB, and reversible, CC plus DB. Okay? So, paano kapag nag-add ka ng A or B? Ano mangyayari, Josh? Saan mag-shift ang equilibrium?
Pagka nalagyan
Shift.
ng E, mag-shift siya sa reactants.
So, pag nagdagdag ka ng maraming A, ano mangyayari sa siso mo? Dadami yung reactants mo. Paano mo ma-regain ang equilibrium? You
Mm,
form what? You form more products or you form more
form more
reactants?
product.
Okay, so anong direction yun? Shift to the left or shift to the right?
Shift to the left.
Pag shift to the left, ibig sabihin you're
More
forming more
reactants.
reactants.
So more product, shift to the right.
Okay. Shift to right. Okay. So ngayon, um, hindi mo babaguhin yung K mo dyan kasi nga nire-retain lang natin yung equilibrium mo. So, the next one is paano kung product side yung dinadagdagan mo? Add C or D. So, of course, the reverse will happen, no? Shift to left. Shift to left siya. Tapos, ito yung susunod. Paano kapag volume or pressure? So, usually, gas molecules ang tinitingnan natin kasi sila ang mabilis na naapektuhan ng changes ng pressure or volume. So, ngayon, pag sa gases, Josh, let's say ganito siya, few gas molecules sa reactants papunta sa more gas molecules. Ito ngayon, kunwari yung reaction mo. Paano kapag in-increase mo yung pressure? Saan pupunta, Josh, ang equilibrium? Pressure increase. So, pag in-increase mo ang pressure, what will happen to your volume?
Bababa.
Okay. Of course, boys, so yan, no? Pressure is inversely proportional to your volume. So, kapag tinaas mo ng pressure, lumiliit yung volume, saan pupunta ang equilibrium? Sa mas maraming gas molecule or sa mas fewer na gas molecule?
Mhm. Less gas molecules.
Okay, good. Siyempre, mas magkakaroon ng chance mag-react yung side na mas maraming gas molecule. And nandito, nakikita natin yung product side ay maraming gas molecule. So ngayon, shift to the left or shift to the right with that given condition.
Shift to the left.
Okay, very good. Shift to the left. Or formation ng um, formation siya ng reactants. No? So, syempre, the reverse will happen. If you decrease the pressure, you're actually increasing the volume. So, if you increase the volume this time, yung few gas molecules will be reacting more so that you can form more gas molecule or shift to the right this time. Then finally, increase T, decrease T. This is the last one na factor affecting your chemical equilibrium. Please take note, neither concentration nor pressure nor volume can change the value of your K. Pero ang temperature, kaya niya yan. Di ba sabi ko sa iyo, ang K ay temperature dependent. So therefore, it can change the value of your K. Kaya tingnan mo ha, regardless if heat is retained or heat is being gained by the system, endothermic reaction or exothermic man yan, you will change the K value. Okay? So, if we increase the temperature, increasing temperature, so let's say ganito naman yung reaction mo. So, bigay tayo ng reaction mo. So, reactants
Mhm.
plus heat going to products. So, what is this? Endo or exo? Endo or exo to? Based dun sa binigay ko sa'yo na equation. Endo or exo yan? Reactant plus heat will form the products. Endo or exo, Josh?
Endo, thermic.
Okay, this is endo. Good. So, pag endo siya, tapos tinaasan natin yung temperature, ano yan? Shift to the left, shift to the right. So, tinaas mo yung temperature, dadami to.
Shift to the, wait lang. So,
Dadami yung heat.
dami yung heat.
Sa reactant side,
Shift to the right.
shift to the right. Correct, no? So, you form more products. Very good. Kasi bibigat yung side na to, no? Yung reactant. So, shift to the right ito. Or you form more products. Kasi ito ay isang endothermic. So, pag binabaan mo yung temperature, of course, shift to the left ito. So, this time, babaguhin natin, no? Dito pa rin tayo sa temperature. So, sa taas. Let's say this is your equation already. Reactants going to products plus heat. So, ano to? Endo or exo? Endo or exo, Josh?
Exo.
Exo ngayon to. Kasi magkakaroon ka ng difference dyan eh. Pag in-increase ko yung temperature, ano to? Shift to the left or shift to the right? Exotherm this time.
Shift to the
So,
left.
ito yung bibigat. Okay, shift to the left. Tignan mo ha, magkaiba sila. Pag endo, increasing temperature, shift to the right. But if it's an exothermic reaction, if you increase the temperature, shift to the left. Papunta dito, you form more products. You form more reactants for an exothermic reaction if we increase the temperature. So if we decrease the temperature, this is shift to the right. Yan. This is a good review na rin, no? With our thermodynamics. May concept ka ng thermodynamics, ng gases, etc. No? So, the Chatelier principle, equilibrium talaga siya. Babalik tayo ngayon sa story ni lead iodate, no? So, andito tayo matatapos, Josh. So, this is the question. Diba? Let's go back kay lead iodate, no? If you reform a saturated solution of lead iodate, ito yung nabubuo natin, Josh. So, ito yung mabubuo natin, Josh, pag sa lead iodate. Kapag saturated solution lang ng lead iodate, gaano kadami yung lead 2+? What's the concentration?
Lahat po. X.
Yung X. Ano yung value? Nandyan siya sa slide natin.
Ito na ba? 3 point na something.
3.97 times 10 to the negative 5 molar. Saturated solution yan. Ngayon, ito yung next story natin. So, ang next story natin ganito. What if we will add 0.10 molar lead nitrate sa yung saturated solution? Ulit we will now add 0.10 molar lead nitrate. What is lead nitrate? Soluble or insoluble in water? Soluble or insoluble in water? Lead nitrate.
Insoluble. Ay, soluble. Nitrate.
Soluble yan. Highly soluble nitrate ito eh. Highly soluble yan. So, may question ako. What is the concentration of lead 2+ coming from your lead nitrate? Yeah. What is your concentration of lead 2+ coming from your lead nitrate?
0.10.
0.10 din, no? So, wala tayong pakialam kay nitrate kasi wala siyang effect. So, ibig sabihin, Josh, you added what? Reactant or product?
Product.
Okay, nag-add ka ng product. So, by Le Chatelier principle, if you added increased concentration ito, ano mangyayari? If you add more products, ano dito sa specific reaction na ito, ano mangyayari? Mag-shift to the left or shift to the right?
Shift to the right.
So, shift to the right. So, pag nag-shift to the right ka, you're forming more lead 2+ and iodate. Tama ba?
Opo.
Hmm, sige, analyze mo. Paano naging Le Chatelier principle yun? Tingnan mo, balikan mo yung equation mo. Ayan, o. Ito yung equation mo, Josh. So, You increase already lead 2 plus this time.
So, increase lead 2 plus. Ngayon, magkano siya ulit ng
Kasi nagdagdag ka ng lead nitrate eh.
shift to the,
So, saan siya? Shift to the?
shift to the left.
Okay,
Kasi
so shift to the left dapat to.
sobrang dami na pong lead din.
Oo. So, shift to the left. Anong masasabi mo sa solubility? Increase or decrease?
Decrease.
Okay, dapat decrease solubility
Common
to.
ion effect.
Oo, correct. Ito ang tawag dito ay common ion effect na discuss to for sure ni Sir James, decrease solubility. So if you now have decreased solubility, we need to prove that. Dapat bababa yung concentration ni lead 2 plus. We now use the ice table again. So ice initial, change, and then at equilibrium. Oh, question, Josh. Kasama ba yung lead iodate sa calculations?
Hindi po. Hindi po siya soluble.
Okay, exacto. Initially, meron ka bang lead 2 plus?
Wala.
Meron na. Kasi nagdagdag ka, ayun Yun Di ba you added a lead nitrate here?
Opo.
So, ano ngayon yung initial concentration ni lead?
0.10.
0.10, good. Tapos si iodate, meron ka ba?
Wala.
Okay, 0 pa rin. Tapos ang change, plus,
Plus x pa rin po.
eto,
Plus 2x.
yun, magbabago ngayon to. So, magiging x plus 0.10 ito, or 0.10 plus x. Ito ay 2x. Ano yung value ng KSP mo pa rin? KSP is equal to lead 2 plus times iodate negative
Squared.
squared. Okay? So, this will be equal to x plus 0.10 times 2x squared is equal to, ano yung value ng KSP natin? KSP is 2.5 times 10 to the negative 13. 2.5 times 10 to the negative 13. So, let's now calculate x. Kasi yun yung mahalaga no? So, let's calculate x this time. Pa-simplify nito, Josh, magiging 0.10 plus x
Quadratic.
raised to 2x squared to, no? 4x squared, right? So, 2.5 times 10 to the negative 13. 4 times 0.10, that's 0.4. Bakit ako nag-calculate?
X squared.
0.4 x squared plus 4x cubed, correct? Is equal to 2.5 times 10 to the negative 13. So, this is a quadratic equation. So, yeah, quadratic. Ano siya? Cubic equation.
Cubic pero isang x po is 0, which is impossible.
Yes. So, 4x cubed plus 0.4x squared. Ililipat ko na siya minus 2.5 times 10 to the negative 13 equals 0. Para at least makakuha natin yung value. So, i-calculate lang natin siya. Equation. Oh, I forgot what is the equation here. Inequality. Ayan, equation.
A.
Yes. Ito na siya. Tapos polynomial yan, di ba? Tapos degree 3. So, ang ax cubed ko, ang a ko ay 4. Tapos, ang x squared ko ay 0.4. Kaya ng calculate natin hanggang hanggang 4. Ang x ko ay 0.
I don't think kailangan po ng 3 kasi in the end po magiging x equals 0 yung isang solution. So, pwede na rin siyang quadratic.
Yeah, pwede rin naman. Pero, yan. Ayoko na siya sa math. Actually, hindi ko na siya alam. So, ayan. 3 roots yung makikita natin, pero dalawa sa roots mo ay negative. So, impossible naman yun, di ba? Negative yung concentration. Kasi concentration yung hinahanap natin eh. So, hanapin lang natin yung mass, yung positive na x. So, dito yung positive na x ay 7.91 times 10 to the negative 7 molar. Sino yung X ulit, Josh?
Yung ano po, yung lead galing sa lead iodide.
Very good. Lead 2 plus from iodide. Ngayon, ikumpara natin siya from lead iodide. Kumpara natin siya dun sa lead natin kanina. So sa lead natin kanina, it's 4 times 10 to the negative 5 or 3.97 times 10 negative 5 molar. Tapos, nung nagdagdag tayo ng lead nitrate, 0.10 molar, ano nangyari yung sa lead na nanggagaling kay lead iodide? Nag-increase or nag-decrease?
Nag-decrease.
So, kitang-kita natin no, yung common ion effect will decrease the ions coming from your lead iodide. So, therefore, ano mangyayari sa lead iodide? Mas mag-decrease or mag-increase yung solubility?
I-decrease po.
Decrease. So, actually, ito na yung new solubility of lead iodide in the presence of lead nitrate. In the presence of lead nitrate. So, yan, clear tayo siya. So, kung makikita mo, dahil lumit yung X mo, liliit din itong iodate mo. No? So, what's your new iodate this time?
Mhm. 2x
That's 7.91 exponent to the negative 7 times 2. That's 1.58, no? 1.6 na lang.
times 10 to the
Times 10 to
negative.
negative 6 molar. That is your new concentration ni iodate. Imagine niyo ha. Imagine mo, Josh, from 7.9 times 10 to the negative 5 molar, the iodate ions this time decrease to 1.6 times 10 to the negative 6 molar. Let's check. Ayun, tama, no? 1.6 times 10 to the negative 6 molar for iodate. Tapos, for your lead 2 plus, that's 7.91 times 10 to the negative 7 molar coming from your lead iodate. But please take note, may tanong ako, Josh. At equilibrium, what is the concentration of lead 2 plus at equilibrium?
Mm. No. Ano ba?
Ito siya.
Halos 0.10 po.
Oo, correct, no?
7.9 times 10 to negative 7. So,
Yeah. So, pwede na nating isabihin na 0.10 molar kasi very negligible yung nanggagaling kay lead iodate na lead 2 plus. Okay? So, yeah, that's it, no? So, I think we'll end with this one. So, ayan, may final slide pala ako dito, no? Before we proceed with water equilibria. So, next meeting, water equilibria tayo. Ayan, pwede na rin tayo, I think, mag-start sa organic. Basta matapos natin yung acid-base equilibrium. Kasi ang kasunod ng acid-base ay hydrolysis and KSP. So, okay na yun. Basta tapos na natin yung acid dissociation, base dissociation, KA and KB, doon lilitaw yun. So, okay na tayo doon. No? So, I hope this one is clearer to you, no? Or so far you recall already your concepts for chemical equilibrium. So,
kailangan
ayan siya.
kaya nga, parang ang kagabi po, may pinapanood na movie. Isang scene lang,
Mm.
natandaan ko na po lahat. Ito po, isang ano lang, isang pagka when I remember one thing, maalala ko po yung
Yeah,
highlight.
successive na
Pero
siya, no?
it will take like 5 minutes po to understand. Pero maisip ko na po lahat. Eventually.
Anyway, so let's just summarize what we have learned tonight. So, yung half ng time natin, no? Chemical equilibrium, it's a dynamic state wherein the rate of your forward reaction is equal to the rate of your backward reaction. Does the reaction stops kapag chemical equilibrium?
No.
No. So both forward and reverse reactions will push through or will just continue. Anong nangyayari lang? Same rates lang sila. Okay? So chemical reactions do not cease at equilibrium. Instead, the amounts of your reactants and products are constant. May tanong ako, how do we describe chemical equilibrium mathematically? We need the
The equilibrium constant po.
very good. So, pero yung equilibrium constant is just a ratio of your products and reactants raised to their respective stoichiometric coefficients, correct? We can also have ratio for that. Paano kapag hindi equilibrium? Anong tawag natin doon? Sa ratio ng product and reactants raised to their stoichiometric coefficient. It's not equilibrium constant eh. Ano ang tawag ulit natin doon? Ratio ng product over reactants
Reaction
at
quotient.
any point, reaction quotient. And then yung Q, no? Q and KEQ can be compared, no? If Q is greater than K, saan mag-shift ang reaction? Formation of products or formation of reactants? Q greater than K.
Q greater than K. So more less product.
Okay, papunta dapat sa lasa. So, ibig sabihin, pupunta ka sa reactants mo. Babawasan mo yung products mo, you know? If Q is less than K, if Q is less than K, ibig sabihin, sobrang onti ng products mo. So, therefore, the forward reaction will proceed, no? Or you now lessen the reactants. Paano kapag Q is equal to K?
If Q is equal to K, exactly the same.
Okay, so anong tawag mo doon?
Nasa at equilibrium.
Very good, nasa equilibrium siya. Tapos we already learned the Chatelier principle, no? So, ang Le Chatelier principle is a scenario wherein you added a stress to your equilibrium. The equilibrium will adjust itself so that it can relieve the stress. So, what are your stressors? Sino yung apat na stressors mo? Apat yan. Sino yun? Sino yung apat na stressors mo?
Pressure, temperature.
Temperature.
Ano ba? Yung Boyle's law. Pressure, okay.
Pressure, concentration. Pressure.
Pressure, temperature. Concentration is...
Yeah, concentration, tama. Ng
Sana,
reactants or products.
whatever will affect yung yung concentration.
Mm-hmm.
It will affect the Chatelier principle.
Mm-hmm.
And
ano pa? Boyle's law.
Boyle's law, pressure, volume. Volume, oh my gosh.
Yon, volume, correct. So, pressure, volume, concentration, temperature.
Sabi ko po yung Boyle's law kanina, and then...
Sa apat na stressors mo, sino yung nakakapagpabago ng mga value ni K? Among your 4 stressors, which one can change the value of your K? Isa lang yan.
Concentration.
Oh, concentration ba? If we add more product or if we add more reactants, can we change the value of your K?
No.
At specific temperature?
Kailangan yung temperature makaka-change.
Good, temperature. Because if we increase or decrease the temperature, your K value will change as well. Because K is temperature dependent. Ngayon, yung kinumpute natin kanina, Josh, no, yung concentration as stressor, may tawag pa pala talaga doon. Kung sa Le Chatelier principle. Ang tawag doon ay mass action effect. So, if we're talking about, let's say if we add a product or if we add reactant or we add diverse ion, common ion, may tawag dyan, Josh. Ang tawag ay mass action effect. Sir, itong mass action effect ba ay Le Chatelier principle? Yes. Subcategory siya. Kasi nakafocus lang ito sa concentration. So, sa akin kasi mahalaga sa atin yung concentration because this can affect your system. Okay? So, ngayon, the mass action effect tells us yung typical na the Chatelier principle. There will be shift in the position of an equilibrium caused by adding one of the reactants or products to a system. Okay? So, ngayon, depende yan kung nag-add ka ba ng reactant or nag ka ng product. Okay? So, next meeting will now deal with the different types of K. Actually, naaral na natin to, no? Or naaral yun na ni Sir James. Pero sabi ni Sir James, hindi niya tinoro yung discussion, lalo na sa Ka and KB. Kasi nga, dadaanan kasi ito sa anak no? Sinabi ko din, okay na yan, ipasa natin yan sa anak So, we'll start with KW, followed by KA and KB. May hydrolysis ka pa, which is still involved in K and KB. We'll discuss KSP and then KD as well. So si KD, not KD, not yet. formation constant. Okay? So, formation constant for complexes. Which is, actually, na-discuss na natin to no, sa complexes. Inaral na natin siya. Siguro isang problem lang ang ibibigay ko dyan para lang ma-review mo siya. K-redox ay naaral din natin sa electrochem. So, siguro mas dadaanan natin siya pag nasa redox reaction sa tayo for chemical analysis. So, ang mahalaga dito, Josh, yung tatlo. KW, KSP, KAN, KB, acid base. Si KD, maaaral mo siya sa chrome or separation technique. No?
Why?
Yeah, separation
Why,
technique.
why in chromatography? Why?
Separation technique. Actually, mali yung term ko. Pero may KD rin naman doon. Sa separation technique, yung physical. Alam mo yung, di ba may separatory panel ka?
Opo.
Tama? Yung paglipat nung nakadissolve, let's say sa aqueous mo, versus sa organic mo, may partition kasi sila eh. Okay? So that is another equilibrium. Ayan no? Kunwari, iodine na nakadissolve sa organic versus sa iodine na nakadissolve sa tubig. So as time passes by, we're slowly extracting iodine from aqueous. So ano yan? Sa several rounds yan ng separation. Okay? So with that, we're done for tonight. Ayan. So I'll see you on Tuesday ha. We'll just continue first your K and KB. Okay?
Hindi ko po maalala. Hindi ko po maalala.
Yung ano? Yung?
Mga iba pong concept.
Sige, i-discuss naman natin siya. Okay, sige. See you and enjoy the rest of the night.
Bye-bye po.
Okay, sige, sige.
Exhaustion.
Wait lang, natawa ako doon sa exhaustion. Sige na, good night na.